So the third example we want to give now is when you want to have an initial value. When the variable you have will have an initial value, the value will change later. That's what we mean by initial value. And you are going to make use of the keyword init. So for example, now if you want to compute total score of total score of 5 students in Kursk. In Cox 101. 111. So, what we are going to do now, you must know the input data. So, the input data is score. Score of each student. So we are taking that variable that will take the score of each student as score. Then you have the output data, what you are expecting at the end of the day. So the output data is the total score. So the steps you want to write is like the processing procedure for the processing requirement. So you now can say number 1, or you write step 1. So step 1 is start. So step 2, you will input score of first student. So when you input the score of first student, then another thing that you will need, this one is part of your processing requirement. Another thing that you will need here is also an input, but it is having an initial value, and that is sum. And it has an initial value of 0. Because this sum is a variable, this same total score, which is an output, we have an initial value of 0. So it will, because it has an initial value, it will first of all come up here as total score equals 0. So your total score has an initial value of 0. So after you have started, before you do the inputs, normally it should be set. Init total score to be equals to 0. Actually, we might not need to bring it out here at all. It always reflects in the processing. When we are processing it, that's where it will reflect. So when you start, you will set your initial value. So it needs total score to be equals to 0. Then you will input score of the first student. So when you input score of the first student, what you will do is that you are going to add that score of the first student, you are going to add it to total score. And the value of total score will increase. So also you will, now again you will add the score of the second students to total score again, and the value of total score will change again. You will continue like that until you add the score of the fifth student. So that means that you will be doing something over and over again. You will be doing addition of something to total score. When you will be adding score to total score at least for 5 times. You will continue to add score to total score for 5 times. So because of that, you will need something that we called counter. Something that will help you to continue to keep track of the number of students that you are imputing their score. So in this case now, what we are going to do here, before you start for the first student, what you will first of all do here, after you have given initial score to total score, the next thing you are going to do is to set your counter to. Your counter to will have initial value. So what will help you to be counting the number of students? You will write counter is equal to 0. You will write counter is also equals to 0. So what you will do here is that you will now put a condition there, something that will be helping you to check your counter. You say while counter because it is pseudocode, you will write everything in capital letter. While counter is less than or equals to 5, you will continue to do this. You will continue to be imputing score. So that means that this time all you need to write is impute score. As long as your counter is less than or equals to 5, you will impute score. So, and when you impute score, there are other things that you are going to do. You will impute score, then at the same time you will add the score to total score. So you will impute score and you add the score to total score. So when you impute score, your total score, your new total score now will be equals to the first value of your total score, which is 0. Total score plus the score that you just impute. So after you have done that, you have to increase the value of your counter. So your counter now will increase also. So the value of your counter now will be the initial value of your counter plus 1. Initially your counter is 0. Now you have done it for the first student, so counter will now become 1. So all these step of impute score, they can be a step that they can be steps that comes under your total score, your counter. So they are like steps under while. So all these things will be done as long as your counter is less than or equals to 5. So you will increase the value of your counter by 1. So after increasing the value of your counter by 1, you are not going to do something. You will go back. You will and that going back, you use the word repeat. That's another keyword when you have to do something over and over again. So you will repeat steps 3 to 6. So you continue to repeat step 3 to 6 until your counter is no longer less than or equals to 5. So for example, when counter is equal to 0, when the initial value of counter is 0 in step 2, you check step 3, why counter is less than or equal to 5. 0 is less than or equal to 5. So you go to step 4, you input score. Maybe the score is 5. Then you go to total score. Total score now, since score is 5, total score is equal to total score, the initial total score, plus 5. So you now increase your counter by 1, that you are through with the first person. So 0 plus 1. So you have increased your counter by 1. The step 7 is now telling you repeat steps 3 to 6. So you will now go back to step 3. The value of your counter is 1. So you will now check, is y less than 1 less than or equals to 5? Yes. Then you input score. Maybe that one is also 5. And you already know that total score has become 5 initially or in the previous computation. So the new total score will now be that old total score plus the new score that you want to put in, which let's also take that one also to be 5. So 5 plus 5 will give you 10. So your counter has increased by 1 before, and it has become 1. But now you are counting another student. So the new value of counter now will be the old value of counter plus 1. So that is 2. So you now repeat step 3 to 6 again. So 2 less than or equals to 5. If 2 is less than or equal to 5, you will do everything 4, 5, 6. But you will get to a time when the former value of counter will be 5, and you will increase counter by 1. So when you increase counter by 1, then counter will become 6. I now say 6 less than or equals to 1 or equals to 5. 6 is not less than 5, and 6 is not equals to 5. So at that time, you will get out of the loop. You will not repeat step 3 to 6 again. So you will now go to your step 8, and step 8 will now be output or print or display. So one thing that you will also do, especially when you are doing a repetitive pseudocode, you have to dry run to be sure whether what you have done is correct, especially logically correct, especially with your logical expression. Because if your logical expression is not correct, then the output of your code will not be correct at the same time. In this case, we want to compute total score for 5 students, and the initial value of our counter is 0. So when our counter is 0, we input a score. That is 1. That is the first score. When our counter is 1, we input another score. That is the second one. When our counter is 2, we input another one. That is the third one. When our counter is 3, we input another one. That is the fourth one. When our counter is 4, we input another one. That is the fifth one. So that means that when our counter now becomes 5, this algorithm still allows us to input another one, because if you look at the logical expression, it is less than or equals to, and this expression still satisfies 5 is less than or equals to 5. So it will allow us to input the 6th time. So because of that, that means that this logical expression that we have is not correct. And what we are going to do to make it to be correct, we are going to remove the equal, so that it will not allow us to input the 6th time. So for the 6th time, counter will be 5. So that will be 5 less than 5. 5 is not less than 5. So it will not allow us to do all the iteration, input score, total score, counter. It will not allow us to do it again. As long as 5 is not less than 5. So we can do it this way, or if we still want to keep our equals to, what we are going to do is to change this 0 to 1. Our counter will start from 1 instead of from 0. So we have to be mindful of the initial value of our counter and our logical expression.